Integration video part 1. Number 1. Verify part A. Verify the integration rule. Integral of sine power n ax dx equal all this, right? To verify this, to verify that the integral of sine power n ax dx equal all this value to the right of equal, we can do what? We can take this, right? Sorry, we can take this and we can do what for that? We can derive it. If the derivative of this equals sine power n ax, this is a verification that the integral of a power sine power n ax dx is equal to all this. So what we do is we derive this formula d of this formula, right? D of all this over 2dx, right? What is the derivative of that? Okay, what is the derivative of that? First, its derivative, we derive the first part first. Let's, the derivative of this part, okay? We take the derivative of this part. Minus 1 over NA, it's a constant number, we can keep it outside. And we can multiply all of it by minus 1 over NA by the derivative of sine power n minus 1 ax times cosine ax. This is actually u times v. It's u prime v plus uv prime, right? So let's derive sine n power minus 1 ax. It is simply n minus 1 multiplied with sine to the power n minus 2, n minus 1 minus 1 ax times the derivative of sine ax is cosine ax times the derivative of ax is a, right? This is u prime, and multiplied with v means multiplied with cosine ax plus v prime, right? Plus v prime, derivative of cosine ax is, it's not plus, it's minus, derivative of cosine ax is minus sine ax, and this multiplied with a, which is the derivative of ax, right? And all of those multiplied with sine to power n minus 1 ax, right? It's v prime times u. This is the derivative of v till here, and times u as it is. Plus, okay, let me continue down. Plus what? Plus the derivative of this, the derivative of n minus 1 over n integral of sine n minus 1 ax dx. Simply, n minus 1 over n, we leave it n minus 1 over n because it is constant. The derivative of the integral of sine power n minus 1 is sine power n minus, it's minus 2, not minus 1, ax, right? That's it. All of those now, we should, sorry, this one is alone, right? Because the minus 1 over NA is only for this one. So plus this value here, right? Let's simplify more. Okay, this is A, this is minus 1 over NA multiplied with, it's A times n minus 1 to times n minus 1. Okay, I multiplied this, right, with this. And what do we have else? Okay, we have sine n minus 1, n minus 2, sine to the power n minus 2 ax, and times cosine ax. Cosine ax is cosine squared ax minus a, this is sine power 1, and this is sine power n minus 1, so it gives me sine to the power n ax plus this value over here, n minus 1 over n sine to the power n minus 2 ax. Let's see what we can do else. Let's multiply with this minus 1 over a. A with a cancel. Simply, it is minus n minus 1 over n sine to the power n minus 2ax times cosine to the power 2ax. Minus times minus is plus. Also a divided by a. Cancel, it's 1 over n sine to the power n ax, then plus n minus 1 over n sine to the power n minus 2 ax. We can factorize this with this one here, right? Okay, if we take n minus 1 over n sine to the power n minus 2ax as a common factor, okay, if we divide this term over the common factor, it's 1, minus the other term divided by the common factor, it will be cosine squared ax plus 1 over n sine power n ax, right? Which is equal to n minus 1 over n sine to the power n minus 2 ax. This gives me sine squared ax, right? Plus 1 over n sine power n ax, which is equal to this times this, same base, we add the exponents, n minus 1 over n sine to the power n minus 2 plus 2, it's sine power n ax plus 1 over n sine power n ax. Now we have another common, which is sine to the power n ax multiplied with n minus 1 over n plus 1 over n, right? Which is common denominator n. So it's sine to the power n ax multiplied with n minus 1 plus 1 over n. Minus 1 plus 1 is 0. What left is n over n. And n over n is 1. 1 multiplied with sine power n ax. It's sine power n ax. And this is correct. This is correct because the question wants us to prove that the integral of sine power n ax dx is equal to all this, or the deriving of all this is equal to the integral of sine power n ax dx. So if we derive this, it will be not integral, sorry, it will be sine power n ax, and this is correct. Part B, he wants me to use this formula. We got to make a derivative, to make an integral of sine to the power 3x dx. This is simple. Because just substitution, right? Instead of doing here, simply 5 we consider it as n. N is equal to 5 in this case, and simply a is equal to what? A is equal to 3 in this case. And we just take this, what we got as an answer, and we substitute instead of n5 and instead of a3. Let's do it over here. Let me put the answer aside. So my answer is going to be minus, right, sine power n minus 1 means 5 minus 1 means 4. Ax, it's a 3x. Cosine ax, it's a 3x over n times a, which is 3 times 5, which is equal to simply 15. Plus n minus 1 over n, it's 4 over 5 integral sine to the power n minus 2, it's a 3, right? Sine power 3x dx. Now we are going to simplify this one. So the answer is going to be minus sine to the power 3x cosine 3x over 15 plus 4 over 5 multiplied with, right, minus again, but now a is 3, but n is also 3. So the answer is minus sine to the power n minus 1, it's 2, 3x cosine 3x over n times a, 3 times 3, it's 9, and plus again, right, n minus 1, which is 3 minus 1, 2 over 3, integral of sine n minus 2, it's sine power 3, minus 2, it's power 1, 3x dx. Now we can find directly the integral of this sign, right? We can find directly the integral of the sign, and that will be the solution of our example. So the final answer is going to be simply, the final answer is going to be